In this problem, I have a box being dragged across the floor, and it's being dragged at a constant velocity, and that's going to become important to us later. In order to solve it, I'm going to draw a free body diagram. And from the free body diagram, I'm going to sum up the forces in the x direction, the y direction, and I'm going to use my definition of friction. Friction is equal to mu times eta. So I'll use that to find out what the coefficient of friction is. So let's start with the free body diagram. All right, to begin with the free body diagram, I'm going to start with a dot, and that'll represent the box. Now what I want to know is all the forces that actually act on the box. Not all the forces the box exerts, but acts on the box. So now the Earth is going to pull the box down due to the weight of the box. So that's the weight, and I'm going to label that as mg. And I'm doing that because I have 10 kilograms up top, and I'll just make it a little bit easier thinking about things. Next, I have the floor pushing on the box. Yes, the box is pushing on the floor, but I want forces acting on the box. Not what the box does, but acting on the box. So that's going to be the floor, and the floor is going to push up with a reaction force, and that force is called the normal force. And the normal force is normal to the floor. In other words, perpendicular. That's what normal means. Then I've got a tension, 30 newtons. So I'll write that as T. I'm not going to write 30, but I want variables for all this. And I know the box being dragged. It has friction because I'm looking for the coefficient of friction. So I'll have a frictional force go in the opposite direction of the tension. Friction cannot initiate motion, so it's got to be moving from left to right in this case. And friction opposes motion and is parallel to the surface. So there's my free body diagram. Next step, let's sum up the forces in the x and y directions. All right, I'll sum up the forces in the x direction. That's going to be equal to either 0 or mass times acceleration, which is the net force. So it's one of those two. In this case, it's moving at a constant velocity up here. So because it's moving at a constant velocity, I know it's going to be 0. So that's equal to 0. And I'll say all the forces pointing to the right minus all the forces pointing to the left. That makes this easy. Next, I'll sum up the forces in the y direction. And that's equal to, again, 0 because it's not changing speed in the vertical direction or the y direction. And I'll say all the forces going up minus all the forces going down. Great. Now when I look at this, that only gives me two equations, and they really don't connect to each other, on face value at least. T minus friction is equal to 0, so that's going to say T equals friction, and cursive F is my frictional force. And the other one is going to say that eta minus W is equal to 0, so in other words, eta is equal to W. So those are my two equations. I'll just list them as 1 and 2 just to make my life a little bit easier when I explain things. So they're equal to each other, but I still don't have the coefficient of friction anywhere, and these two equations don't seem to relate to each other, but they do, because I know the definition of friction. Friction is my cursive F. That's equal to mu, which is the coefficient of friction, times the normal force. So I'll make the Greek symbol eta. So there is my friction. I'll call that equation 3, just so I can talk about these things. Now what I'm going to do is I'm going to start connecting the equations and using mu. There are a couple ways I can do this. What I'm going to do is I'm going to take my equation for friction number 3 and I'm going to put it in wherever there's a friction force in equation number 1. So that's going to leave me with tension is equal to mu times eta. So I'll call that equation 4. Now, still, I have a problem. I don't know what eta is, but I know that eta is equal to the weight. So for let's see, my next equation over here, I'm going to say that tension is equal to mu times the weight, which means tension is equal to, oops, I shouldn't have done it like that really. Let me back up just a little bit here. Tension is equal to mu times mg. Now I need to isolate mu, so I'll put mu all by itself by dividing both sides by the mass and both sides by gravity. So I'm going to treat these as if they're one number. So that means that mu is equal to the tension minus mg. So therefore, mu is equal to the tension, 30 newtons. Notice that I didn't use any numbers anywhere in my problem until I got to this point where I'm actually doing the calculations. And that's divided by mass times gravity. So that's going to be 10 kilograms times gravity, which is 9.80 meters per second squared on the Earth. So if I do the math, I get mu to be 0.306. So the coefficient of friction is 0.306.